Now, how can SELINUX help? SELINUX brings an additional layer of security, so it is not a replacement of the traditional security method based upon IDs and permissions. It is an addition to that. After the traditional permissions have been checked, SELINUX will step in and perform an additional check. Now, how does that work? All subjects will have a label, and when you create new files in your system, these will also be labeled if SELINUX is active. And simply put, a subject is only able to access an object if the labels match. Conceptually, we could look at it like this. Imagine a process gets label A, and on disk there are files that also have label A. Another process gets a different label, and there will be files on disk that will match that particular label. Now, if the process that has label A tries to access a file that also has label A, the permission will be granted by SELINUX. Of course, first traditional access will be checked, so SELINUX does not have to step in if the user ID has no read, write or execute permission, because, as stated, the order is first discretionary access control and then SELINUX. If the same process with label A tries to access a file that has label B, permission will be denied, irrespective of the user ID. So even if the user ID is 0, or in other words, the root user, permission can be denied by SELINUX. This is referred to as mandatory access control because the operating system itself will step in. So the traditional security mechanism of discretionary access control is complemented by mandatory access control. Now, what about these labels? A label contains the context type, and labels with the same context type belong to the same domain. Now, the domain can be regarded as a container or a sandbox kind of thing. It simply means that by default, context types cannot break out of their domains. So basically, as discussed, a subject with a particular context type cannot access an object that has a different context type. Now, this is all based upon policies and rules in policies, which are managed by a Linux security module, which has hooks into the kernel. Now, please check out this page for some more information. Now let's get back to these context types. So for example, the password binary has the context type password in its label and is of the password_exec type. And so if you run the password command, that process is not allowed to touch the /chttpd file because it has a different context type and it is in a different domain. Now let's see what this looks like in real life.